This is the introduction to section 6.6, part 1, and we're going to be talking about trapezoids and kites in section 6.6. In part 1 here, we're going to talk specifically about trapezoids. Now, a trapezoid is a quadrilateral with exactly one pair of parallel sides. So it is different than a parallelogram or any of the other three shapes we talked about. Okay? The parallel sides of the trapezoid are called the bases. So, as you can see from this picture right here, in this case the parallel sides are called the bases. The non-parallel sides are called the legs. Okay? The two angles that share the base of the trapezoid are called the base angles. So it's got essentially the angles here are the base angles, along with the top ones. Trapezoid has two pairs of base angles, bottom base angles and top base angles. Okay, now, we're also going to talk about, in this case, a more specific trapezoid, and that's what we call an isosceles trapezoid. Now, an isosceles trapezoid is a trapezoid with legs that are congruent, just like an isosceles triangle. It has two legs that are congruent. On an isosceles triangle, an isosceles trapezoid has two legs that are congruent to each other. In this case, the two legs that are congruent to each other are not the parallel sides. So you'll see BC and AD are the parallel sides. The sides that are congruent to each other are A, B, and C, D. Okay, so let's talk about some properties of isosceles trapezoids. First property is the fact that if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So you see trapezoid TRAP here, okay? Trapezoid TRAP, it's an isosceles trapezoid, which means these sides, these legs are congruent to each other. So each pair of base angles is congruent. So in this case, angle T and angle P are on the same line that's parallel, so they're congruent to each other. They're base angles, T and P. A and R are on the top base angles, so in this case, A and R are congruent to each other. Now, T and R and A and P are not congruent to each other as you're looking at those. It's the base angles. So, let's take a look at some examples now. Finding angle measures in trapezoids. It says CDEF is an isosceles trapezoid. Measure of angle C is 65. What are the measure of angle D, E, and F? Okay, now, same rules still apply in terms of a quadrilateral as well. So you have an isosceles trapezoid. As you're looking at this, you have C, which is right here. The other base angle that is with angle C is angle F. So in this case, angle F is going to be 65 degrees. So these two angles are going to be congruent to each other. Okay. Now, these are still considered C and D consecutive angles. And whether it be a trapezoid, a kite, whatever, parallelogram, consecutive angles are going to add to 180 degrees. So if I take 180 minus 65, that's going to give me angle D, because they're consecutive, which is 115 degrees. I do the same thing with F and E. If I take 180 minus 65, that's going to give me 115. So angle E is 115 degrees. Okay? So you're still using some concepts from parallelograms, or quadrilaterals, excuse me. Consecutive angles are supplementary. Okay? All right, number 2, it says in the diagram, PQRS is an isosceles trapezoid. Measure of angle R is 106. What's the measure of the other angles? Hit pause, come up with the 3 answers, and see if you're correct. Okay, now that you've hit pause, we know angle S is going to be 106 because these are the two base angles. So they are congruent to each other. Okay, they're congruent. And then I know that Q and R Q and P, not R, Q and P are supplementary to both R and S. So in this case, if I take 180 minus 106, I get 74 degrees. And angle Q and P are going to both be the same. So they are both 74 degrees. Okay, a couple other characteristics of isosceles trapezoids. Another characteristic of an isosceles trapezoid is that the diagonals are congruent to each other. So in this case here, you have an isosceles trapezoid. You'll notice that AC and BD are congruent to each other. That only happens in an isosceles trapezoid. Okay. One other thing that we're going to learn with trapezoids, and that's what we call the midsegment. The midsegment is essentially the segment that joins the midpoints of its legs. Okay? The midpoints of its legs. So the point exactly in the middle of RT and AP is M and N. So the midsegment is right here, MN. So there are two things with the midsegment. First of all, in a trapezoid, the midsegment is always parallel to the bases. Okay, it's always parallel to the bases. Secondly, the length of the midsegment is half the sum of the lengths of its bases, and that's what you see right here. Okay, MN is the midsegment. That's equal to half times the two bases added together. Now, I'm going to rewrite this so it's a little bit easier to see here. Okay, the midsegment is equal to, and we'll write this as base 1, that's TP, plus base 2, which is RA, all divided by 2. That's another way to write it. It's a little bit easier to understand that way too. Okay, so I take the top base, the top and the bottom, add them together, and then divide it by 2. That's going to be your midsegment. Okay. Okay, so now let's take a look at an example of this. It says QR is the midsegment of trapezoid LMNP. What is the value of X? So I know, again, that the midsegment is equal to base 1 plus base 2 divided by 2. Okay? So as I set this up here, which one is the midsegment? Well, this is the midsegment. That's the midsegment. We'll count this as base 2. We'll count this as base 1. So all I'm going to do is substitute it in. X plus 2 equals. Base 1 is 4x minus 10. Plus base 2 is 8. All divided by 2. And now I have to solve the equation. So what I'm going to do here is I'm going to multiply by 2. Everything here by 2, which I get 2x plus 4. I distributed there so it saves a little bit of time. Equals. The 2's here cancel. 4x. And then negative 10 and positive 8 is a negative 2. And now I can finish solving. I subtract 2x. So now 4 equals 2x minus 2. If I add 2 to each side, I get 6. And in this case, x is equal to 3. Okay? So that's an example of using the midsegment. Now, let's take a look at this example. In this one, it says MN is the midsegment of trapezoid PQRS. What is X and what is MN? So again, the midsegment is base 1 plus base 2 divided by 2. This right here is the midsegment. This is base 2. This is base 1. I always do that on these types of problems so that I know exactly what I'm looking at. So the midsegment, 2x plus 11 equals base 1, which is 10, plus base 2, which is 8x minus 12, all divided by 2. Okay? So, I'm going to go ahead and multiply by 2 on each side. Again, got to multiply everything by 2. So I'm going to distribute 4x plus 22 equals, 2's cancel, 10 minus 12 is negative 2. Okay, so I end up with 4x plus 22 equals 8x minus 2. Subtract 4x, so 22 is going to equal 4x minus 2. Add 2. So 24 equals 4x, and if I divide by 4, x is going to equal 6. Now, remember, we didn't want to know just the value of x. I want to know how much is mn. I need to plug it in. So 2 times 6 plus 11, which this is 12 plus 11. So mn is equal to 23. Okay, so we talked about trapezoids, isosceles trapezoids. We talked about mid-segments of trapezoids and the different properties. Okay, this concludes section 6.6 part 1. Don't forget to complete your WSQ.